So just before we get started, you probably are tracking this, but we got 5 minutes and we'll stop here and we'll try to answer some questions.
Okay. As he said, my name is Logan. I am the lead designer when it comes to our bot, and the first thing I'm going to talk about is the whole entire sketching process when it came to this. And in the very beginning, we all had our own notebooks to record our own data. And from our whole entire design aspect of what we saw from the video, we decided to go with a crane outlook. And this is our final copy, as you see right here. And so it's been able to improve more and more. And what we needed to do is create some prototypes. If you want to go ahead and show it right there. This is our last, this is our Tetrix model that we used for the crane lift. But we realized that it wasn't necessarily heavy or sturdy enough to pick up the blocks that we needed it to do. And so we improved it by redesigning it into the double worm gears right here. And so this has been extremely effective, and this has been our final design, which has been very successful. The next thing I'm going to talk about is our unique item that corresponds to the whole entire game, and that is our head right here. And from the very beginning, we've had different designs, and this being one of them. And this design, we saw a couple flaws with it not being sturdy enough for it to lift the block, and it would actually break sometimes with the Tetrix model down here. And so we were able to improve it more and more by adding some slides and some fillets along here, and that's been able to be extremely successful and sturdy.
Hi, my name is Dave, and I'm going to talk to you about our mentors. One of the things that we were able to do during our off season was go over to Caterpillar and do a presentation on our robot here. So therefore they could see if they wanted to invest in us. As a result, they let us borrow one of their engineers. His name is Brian Baker. He works for them as a design engineer, and we were able to use that aspect to help us design our robot and get it to the design that it currently has. Another engineer that we were able to get, he's retired, but he was the electrical engineer. His name is Arnold Banning. And he came in and helped us fix our servos because we kept having problems with them. And he helped us finally figure out how to properly wire the robots if we'd have lesser complications with our wires. Then we also had an engineer from Exelon, the nuclear power station in Clinton. He came in and helped us figure out how we were going to properly use our double worm gear drive for the head, so therefore we wouldn't have any feedback issues from our later model. And our final mentor that we had come in was Nathan Weeks. He came in and helped Sam and Jonathan with our coding and to properly get the bot running and what exactly it was all going to do. Over to you, Jonathan.
My name's Jonathan, and I'm going to talk about our connection with other FTC teams and FLL members. What was really cool at the beginning of the season was that we were able to hold a kickoff event for a local FTC team. So 2 local FTC teams came over, we ate pizza, watched the video for the event, and we were all able to strategize together of what the robot would have to be in order to complete that. We also held a community engineering night where FTC teams came over and talked to little kids who were both in FLO and interested in FLO or FTC. And they were able to drive the bot, ask questions on how it worked, and at FLO Qualifiers, we did the same thing and did a demo of our bot for all the teams competing there. And actually, one of our seniors, Logan, was able to get on a local radio station and talk about our school and our FTC program.
Alright, so as I said before, I'm Sam. I'm going to talk about programming and the overall design of our robot. So last year we had many different systems come together to make our robot, and it was kind of just a mix match of like different colors and stuff. So this year we want to make sure like it looked aesthetically pleasing. So Logan did a great job designing a large portion of our robot, 3D printing it, and we added LEDs this year to make it look even better. And so it just has an overall industrial look. And then for coding, this year we wanted to step up our game a large portion, and so we decided to add mechanism wheels, and that requires a lot more coding, so we had to use vector addition from physics to actually program how to move the wheels depending on what direction it's heading and the different power to each wheel. And then we also added a camera in front, so it uses TensorFlow object detection, so it can detect the sky stone in the actual shape and color of the block to pick it up during autonomous. And yeah, so just coding from last year and this year is a huge difference, and we really stepped up our game this year.
That's
Yeah.
5 minutes.
That's our presentation. So any
Perfect.
questions, go ahead and ask us.
His professionalism as, and how did you demonstrate that?
Yeah, so for basic professionalism for me is respecting other teams, working with other teams, helping out in the community. And we did all of that we had some scrimmages with other teams, as John said. We practiced with them. We helped out with the FLL and demoed for them. Yeah, they let us borrow their machines, and we also strategized with a lot of other teams. Yeah, so anything else to add?
Yeah, when it came to working with other teams, we've been able to discuss like different ideas that we could use when it came to actual competitions, and we were able to give ideas and actually take ideas from other teams. And we've been able to really work with other teams, which has been a great help.
So the camera's just, you mentioned TensorFlow, is that basically what the camera's?
Yeah, it's used mainly for autonomous and detecting the skystone on the build side, or the load side.
What all can you do in autonomous?
You want to answer that?
Yes, our main autonomous program pulls the tray and puts it in a corner, but we turn it 90 degrees first, and then we have two of those programs, one to park on wall side under the line, one to park on bridge side. And after we park on bridge side, we extend our linear actuator, which lengthens the total length of our robot, so that we can place the first block exactly from the distance we want it to be at in Teleo.
And then for the other side, we so the blocks are usually in the first three positions, so we detect and see if it's in the first position. If it's not, then it moves over, and side tries to see if it's in the second. If it's not, then it moves over, and hopefully it's in the third one.
So you can move the foundation, you can grab one or two sky stones, and you can park.
Yep.
Are you ever put the sky stones on the foundation?
We are not. We just drop them off on that
Both?
side. Usually it's just one.
So you score how many points usually in?
I think it's 4 for the skystone, and then parking on the line.
And moving the foundation.
Yeah, and moving the foundation.
That's pretty good. So, can you explain how the lift works? Or the grabber?
Logan, do you want to talk about?
Yeah, so we have a linear.
Yep.
So we have a linear actuator right here, and Jonathan wants to go ahead and demonstrate. So it goes in and out with the motion. This will tighten the block, and we also have a servo right here, and so we'll rotate the block if needed. If it may be sideways, we're able to rotate it and be able to put it back on the foundation. You can also lift and tuck our head.
You can also turn the head too, right?
Yeah, we can also turn it. And so this allows it so that if the block's like this and we stacked high, we can put the crane out like this to get extra distance and then turn it to be able to face it, do it downward.
So how high have you stacked?
We can physically do 8 high and then capstone, but on average we get about 4 and then capstone during matches. Alone, stacking just by ourselves.
You can ask him about that question in the book.
Yep, so there was, on page 61, I think it made us,
It was the multicolored,
it says, we set the hardware configuration up as a servo and use the set position command to get, so that goes on to talk about the lights. What does it mean by hardware configuration set up as a servo?
So the lights actually plug into a servo port on the rev hubs, and then we can use coding to actually, based on what direction we move, change the color of the lights. So when we go forward, it's green, back up is red. So the straightening the sides blue, yellow, and then turning blue.
And
so the color is more than just a show thing.
Yeah, it's actually signals
Yes.
to our
It gives you
direction
feedback
to
of what's
our,
happening, right?
yeah.
and it sends those signals through like a kind of LED translator here in the back, which changes the colors on the lights.
So the wheels, like you mentioned, I think you mentioned you had to do like, did you say vector math due to the
Vector
wheels?
addition.
So what's the advantage of using these wheels over?
So instead of just regular wheels, we can actually strafe and turn, so we can do more than just a tank turn. With mechanism wheels, we can slide over And then it's a lot more, I think it's more quick. Logan, what do you think?
Yeah, I would agree with that. I believe it is extremely quick, and then also when it came to strafing and backing up, it's actually.
It's very helpful.
Did you
Trying to
have any
stack.
difficulty, was it not working quite sideways when it's straight?
During autonomous, it's very accurate, but sometimes the gyro, it just like kind of turns off a little bit, so it's like a little angled, but it's not usually a problem. But so it works pretty much every time.
At the beginning of the year, the only problem we had is that we did have some chains being loose, but we fixed that problem very soon in the year.
So how do you program, autonomous, go time, distance, how do you know what?
We do distance, so we use encoders to translate the ticks from the encoders on the motors into inches, and we use a math calculation and encode. It's in the book in the back. And so we base it off distance, so it straights over for so many inches and then goes forward for so many inches and then backs up and turns.
Do you guys have a sustainability plan for your team?
Yeah, so we have a lot of interest from the rest of our school. So this is our second year in FTC as a school, and a lot of people didn't know what it was. So next year we're having, I think it's a couple more people join, and then we are also planning on doing some more demos for different companies to get some grants or sponsorships for next year.
So what do you do for fundraising besides, you mentioned the grant from Caterpillar, do you do any other fundraising?
We got a grant from FTC this year. We also got one, I can't remember, ADM gave us one too. I think
Tell me a little bit more about the community engineering night, is that like a school thing, or what is that?
trying to talk about
It was hosted at our school. It was mainly set up by our teachers, and really just two of our local FTC team came, and a lot of elementary through middle school from either being related to people who went to our school or going to the school themselves came, and they took interest in the bot, and so a lot of people came and like they did games and
and it was open to the community, so
Yes.
anybody could come.
About how many people do you think came to your booth?
I'd say like 25 to 50. It's pretty good group.
You guys do anything with social media? You got Instagram, Facebook?
We did not have social media for our team yet. We were talking about it earlier this season, but we decided not to do it this year.
So it's just 4 of you?
Yep.
Yes.
Just 4 of us.
How many seniors?
2. Yeah. And like we said, we should have more coming up next year. We have some interest.
Recruiting through school and some of
Yeah.
those events like that.
Yeah, and homeschoolers too.
Oh, that's good.
Are you guys from the Peoria area?
Decatur.
You work with any FRC team?
We have not.
So what was the biggest challenge you had for this whole project?
I think the head, if we want to talk about the head, like breaking a lot of times.
worm gears.
Yeah, we've had to perfect the head since it was our biggest item, the most unique item on our bot that we really wanted to incorporate. If you actually look on page 73 and 74 in the book, it'll actually show the designs of the head. And so we've been able to perfect it more and more, and as you can tell from the prototype here, it actually had a couple cracks in it, like here and here. And so that was a big struggle to be able to make it sturdier and just more efficient.
But now it's perfect. Perfect every time.
Yeah. And we realized without proper care how fragile worm gears can be.
Yes.
Oh, yeah.
It taught us how to be very careful with some of our parts, especially since early on with our usage of worm gears, a nut had fallen into one of them and ended it very quickly.
So we had to replace that.
And I think you said that the kit that they send the teams, like it comes with some kind of like processing unit. Did you guys stick with the one that they gave you, or did you end up having to get your own?
Yeah, we used the rev hubs. We used 2 rev hubs for our coding.
And you're required to use those.
Yes, I believe so.
Because I was thinking you had the TensorFlow, you have like the fancy light show, you have all that
Yeah,
stuff.
TensorFlow is just a program. It's not actually like hardware. It's
Right.
just a program on it.
I was wondering if all that would be able to run on the one unit that they
Yeah,
sent.
we bought an extra one, so we have 2. Because even just one rev hub only has 4 DC motor ports, and I needed 2. You can only have 2 rev hubs, correct?
I think that's time.
It is time.
Yep.
Thank you, guys.
All right, thank you very
Thank you.
much.
Meeting you.